Okay, we're going to go to the nature of intersection between two lines in R2. So, they've given us two equations and they've given us the variable or a parameter of k. And k actually occurs in both of the equations. Okay. Now k can represent any numbers. And what they've asked us to do is find values of k where we have no solution, one solution, and an infinite amount of solutions. No solution means what in terms of graphing a line? Parallel. We have two parallel lines. One solution means they intersect, and infinite means same line is what it means. Okay, we're talking about the same line. So we need to find values of k that will give us answers to all three of these. So what we're going to do in this question here is we're going to set this up, this equation. And we're going to try to, just the way we did elimination before, we're going to try to get rid of our x over here. We want to work with just our y. So we have equation 1 and equation 2. Okay. So, equation 1 and equation 2. I'm going to take equation 1 and I'm going to multiply it by negative k. Negative k will allow us to get rid of this coefficient k and essentially equal 0 in that long process. So we're going to multiply the first equation by negative k. So we're going to get negative k x minus k squared y is equal to 4. And we're going to get kx plus 4y is equal to 8. When we go to add these two together, negative k plus k is going to give us our 0x. We're going to have negative k squared y plus 4y. We can't combine those two terms because they're not technically like terms. Okay? Our k squared, we're not exactly sure what we're going to be working with there. And it is going to be equal to, oh, you know what I did forget? This 4 should have been negative 4k. It's going to be equal to negative 4k plus 8. Okay? Because technically we multiplied the entire equation by negative k. So this is our third equation now. And our third equation, without that 0, is going to look like this. Negative k squared y plus 4y is equal to negative 4k plus 8. Now, we're going to get into factoring here. We're going to factor these terms and try to make them as simplistic as possible, specifically the variable k. If you look on the left side of the equation, we have a common factor of y. Okay? So what we're going to do is we're going to take y, or divide each of these terms by y, and make it the common factor. So y is going to come to the outside, and we're left with negative k squared plus 4 is equal to, same thing over here, we're going to divide by negative 4, both of these numbers. That'll be our common factor. So negative 4 will come to the outside, and we'll have k minus 2. On the left side of the equation, my variable is a negative. So in order to make it not a negative, we're going to factor out that negative term. So the y will then become negative. So think of it like we've divided by negative 1. And we'll have k squared minus 4. We've taken the negative out of the equation, is equal to 4 times k minus 2. This is something you have to recognize from back in grade 10. Anyone know what this is called? Difference of squares. Okay? So in order to factor a difference of squares, we're looking at the square root of the first term and the square root of the second term will be written like this. A and B, and we're just going to have a plus and a subtraction sign between the two. So we square root both terms. Square root of k is going to give us, or sorry, square root of k squared. Yep, it's just going to be k. And the square root of our term 4 will be 2. Okay? So we're going to get two brackets. K and 2 will be both. K will be the first term, 2 the second, and we're going to have an addition and subtraction sign in there. Will be equal to negative 4k minus 2. Okay? So there is one last step we can do, but I'm far enough along this equation that I would like to start working with what we have. some of you guys will notice that we can move the negative 2k over, bring it over here, and then we'll factor these out. But in advanced function, you guys realize that when we're setting restrictions, the bottom term, or whatever cancels out, still has to be a restriction. So we have to find our restrictions before we simplify past our factored terms. So what you guys are going to do in this case is we're going to think about those three things they wanted us to find. They wanted us to find when we had, what was the first one? No solution, infinite solutions, and one solution. Okay? So we're going to put in terms and try to make these brackets 0. That's our goal here, because we know if we multiply, if this bracket ends up being a 0, this whole side will end up at 0. And same with this. If one of these terms is a 0, the entire side will equal 0. So let's work with our first bracket here. Negative 2. So our bracket k minus 2. If we set it equal to 0, k at 2 will definitely make this side of the equation 0. So we're going to plug in k at 2. When k equals 2, we're going to find out what we get. Well, we're going to get negative y times 2 plus 2 times 2 minus 2 is equal to negative 4, 2 minus 2. This side is going to give us 0 times negative 4. We're left with 0. And on this side here, 0 times 4 times negative y is still going to end up with our 0. So think of it like 0y we're left with. We've seen this before. When we were trying to figure out in 3-space types of solutions. What value of y will give me 0? All. So how many solutions are to this question? Infinite. So right here, this would be a parallel line if k is equal to 2. So if k is equal to 2, we're going to have an infinite number of solutions in this one. Okay? So that's one of the brackets we've dealt with. We dealt with the k minus 2. We'll highlight that one so we know we dealt with it. K minus 2. That gives us no solution. Okay? Let's deal with the other bracket. Now we already have k minus 2 on the other side. We know it's going to do the same thing. So let's try our other bracket here. K plus 2. In order to make that bracket 0, our k value needs to be what? Negative 2. So let's try k at negative 2 and see what we get. We go to plug in, we'll get negative y minus 2 plus 2. Minus 2 subtract 2 is equal to 4. Negative 2 subtract 2. And this will give us 0 again. Okay, negative y times 0 minus 4 is equal to negative 4 times negative 4. Okay. This side again becomes 0y, but on the other side we get 16. What value of y will give me 16? None. There is no value of y that will give me 16. So what does that tell us? How many solutions are there? None. So what's the relationship when k is 2 in this equation? Or parallel, exactly. So we know that if we make k negative 2, we're going to have 2 parallel lines. So we've got rid of no solution, infinite amount of solutions. Now, whatever other number there is in terms of a possibility will give us one solution. So for our k value for the last one solution, k can be anything except negative or positive 2. Or if you guys want to write it, plus or minus 2. Okay? So those will fulfill all of the 3 things we've done here. That will give us a value for one solution. That's when k cannot be plus or minus 2. When it's negative 2, it gives us no solution, so we have parallel lines. And when k is 2, it gives us an infinite amount of solutions, so they're coincident lines. Parallel and right on top of each other, we're talking about the exact same line.